So now we'll be going through a summary on chapter 14 and 15. So please take out your math textbook and math notebook. We'll be going through some of the pages over there so that at least we do a recap on or a revision. Okay, so let me give you a rough summary on what chapter 14 and 15 is about. So in our daily life, right, we deal with a lot of data. For example, the price of food, the price of your lunch, the price of anything, or even some numbers that you deal with in your daily life. So now the next thing is, what do we deal with this like data? So basically, right, we would like to like organize it, analyze it, and describe some trends from this data to help us in like predicting the future or something like that. So how to organize data, right? Basically, this is what we'll be learning in chapter 14, whereby we use a dot diagram to represent the data, or we can use a stem and leaf diagram, a histogram, the ungrouped version, or the histogram, the group version, which is the group data and ungrouped data. So what are all this about, right? Let me go through the pages if you're in the textbook. And the next thing is like chapter 14, we also learn how to like describe the data after we have like organized it using the four representation there. So we describe about the range, like what's the difference between the minimum value and maximum value. So minimum value is just the lowest value, and maximum value is like the highest value. So for number 2, the group or cluster. So basically, like would like to see, right, if there's any like data that group around a certain numbers. That means that most of the data is grouping around a certain fixed number, or whether there are any like extreme values or not. That means, right, for example, everyone is scoring like 90 marks, 80 marks, 70 marks, and there are like one person who is scoring 2 marks. This is the meaning of extreme value, the whereby there's a few values, right, that very deviates from the rest. Or whether is there any like symmetry or not, means, right, do we see an equal number of data, right, distributed on both sides? Okay, so let me bring it to the textbook. So on page 292 of your textbook, we will be learning, as in we have learned about the dot diagram. So how does it work, right? Basically, there's this horizontal line here, and this horizontal line works the same way as your x-axis, whereby you need to put the numbers on it, and all these numbers, right, must be of equal units. And so each dot, right, represents one data. Means, for example, if you're doing a survey about the number of students having having the number of siblings, right, you can also use this one also. For example, if I can say that there are like 6 students that have no siblings, you put 6 dots on the 0. And if there's like 7 students who have like 1 sibling each, you'll put like 7 students here, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. This is how you represent the dot diagram. Because if we just put the data as by itself, right, like put all the numbers together, it'll be very hard to like see or analyze. That's why we need to use diagrams like this case, right, to represent it. So by looking at this data alone, we can also see like what are the extreme values also. For example, this 55 over here is like completely different from the rest, or the rest is like over in this region. So this is the meaning of extreme values. And whether there's any like symmetry, for example, is this curve like equally distributed for the data? No. In this case, right, most of the data, right, are like concentrated or like crowded on the left side, while for this one, most of the data, right, are like concentrated on the right side. Okay, so for the skewness, right, it just means, right, if it's a right skew, it means that it has a long right tail. That means this is the tail. Then if it's a left skew, it means you have a long left tail. Okay, so if you're unsure about how to use the skewness to describe, right, you can actually focus on the rest on top. For example, you can describe the range, cluster, or any extreme values, or any like symmetry, if the last one is too hard for you. So don't worry about the last one. So in the dot diagram, right, is that sometimes we notice that it's very hard to like write all those individual datas. Like for example, it's very hard to write 25, 26, 27, 28, 29, all the way like individually 31, 32 until 40. It's like too many numbers to write. So we can actually do it in this manner, whereby you show that you have a fixed interval, like for example 25, the next number 30, just like how your measuring cylinder works as you read the readings. So if the data is like too much numbers, you can actually like do an interval marking like 25, 30, 35, 40, or you can write 22, 24, 26, 28, depending on like which one is comfortable for you. Okay, so normally for a dot diagram, as compared to like the other diagram also, all of the diagram, right, they'll normally ask you like what percentage of the students have a certain something like that. So you also need to like recap how to do percentage also. And they will ask you to identify, right, how many students fit into this category and stuff. So you need to know how to like interpret the data. And lastly, they'll ask you to describe briefly the distribution of the data. So for in this case, you can say that the mass of the children range from this 28 kg to 40 kg. So basically you're reading off the minimum value, the lowest value, and the highest value. And you can also talk about whether there's any like data that is very totally different from the rest. That's why they are called an outlier, because you're like out as compared to the rest. So we have gone through about the dot diagram. So for the stem and leaf diagram, right? So this one is a stem, this one is a leaf. So you need to write the heading so that we know that what numbers you're referring to. So an example of this stem leaf diagram, an advantage, right? It will be that we can easily observe any distributions, or we can also observe whether there are any cluster of data, or if there's any like extreme values also. So the shortcut here is that the stem over here represents the number in the tens place, while the leaf, right, represents the number in the ones place. So for example, if you have a 24, you put 2 here and put 4 here. So this one is 24. So an important thing to take note is that you need to put a key over here to tell us, right, what does that number in your stem and leaf diagram represents. For example, 2/4 means 24. So if the stem and leaf diagram, the situation, the questions, it has some form of units, right? You need to put down the units. So for example, if you're talking about the weight or the mass of students, right, in a class of like 30, you have to put a key and choose one of the value, any values given to you in the table, and write down what does that single data means as an example. So an important point to note when you construct a stem and leaf diagram, right, is that you need to arrange in numerical order. And the reason being, right, if you don't arrange in numerical orders, right, it'll be very hard for you to like trace which one have you like written down or which one have you not written down. So that's why it's always good to organize the data, just like how you organize your data to calculate the median. It's the same thing also. So you normally like arrange from the smallest to largest. So smallest being on the first row, that means the horizontal one, followed by the largest. And the largest number, right, is always on the furthest right side. As you can see over here, 48 is at the most right side. And you also need to check, right, whether the number of leaf, so this one's a leaf, whether it corresponds to the total number of data, right, given in the questions. So if you realize that the total number of data when I write down in the leaf, when I write down in the leaf, right, it doesn't really tallies with what was the total number given in the question. That means that you might have missed out some value. So that's why it's always good to check the stem and leaf diagram, because these are like, which I can say like free marks. As long as you just do it like systematically, right, can get the marks easily. Okay, so for example, in this case, right, you'll be always given like if we want you to draw a stem and leaf diagram, you'll be given a set of data. For example, in this case, the masses of like 10 salt containers, and you realize that all these numbers, right, are not like arranged in order. That's why you need to arrange in order first before you can present it in a stem and leaf diagram. Okay, so I won't go through the details. You can read it by yourself. Okay, so what if some cases, right, whereby you have a very long leaf? Okay, long leaf means, right, that one of the particular data, right, you have a series of data, right, that falls within that tens place. So you can actually like do it in a split stem. Split stem means, so for example, this case, you notice that the 50s region, right, it has a lot of data over here. So what you can do, you can split up the stem into two. So you can split up the leaf into two parts. Because you can split up the stem into two parts. So for the stem, right, into two parts. The first stem will be like for the number from 0 to 4. The next stem will consist of the leaf, right, from 5 to 9. So you can just split it up into two parts. So don't worry when to like split stem. We will tell you in the questions if you need to do so. Okay, so you see, right, they always ask you to find percentage. So percentage is like a very common concepts in chapter 14 or even chapter 15 as well. And when there's a unit involved, right, you need to put down the unit. For example, this $48 over here. Just pick any values to write down this key over here. Okay, so now the next part of the stem and leaf diagram is called the back-to-back. So back-to-back, right, we only use when you have like two different population, means two different sets of the group, two different groups. Because sometimes when we want to like draw two stem and leaf diagram is very tedious. Like two separate stem and leaf diagram is very tedious. That's why we like combine them together. So you have one stem and two leaf to represent the different groups. So it's like group A and group B. So in this case, these are all the data in group A, which is the habitat A, and which means like a location A, and there's a habitat B, which is like a location B. So for the group A, right, normally we write the smallest number nearer to the stem and the biggest number, right, further away from the stem. That's why your 58 is at the end. Same for your 59 also is at the end. Yep. So you also always need to write the key down, because when I mark, right, most of you forget your key, which is very bad. Yep. So this is all your stem and leaf diagram. So if you need to highlight, you can highlight over here. So now we move on to histogram for ungrouped data. So what does it mean by ungrouped data? It just means when the data are not grouped together. Okay, so when you're given data, right, there will be this series of like data over here, like so many of them, and they are not like organized, because maybe like collected from students from register number 1 to 40, and all of them like score different numbers and they are not arranged. So that's why we need a frequency table to arrange them, so that when we want to analyze the data, right, at least we can like analyze it better. For example, I can know that, oh, how many students score A1, how many students score B3, how many students score C5. It will be like easily seen just from this frequency table alone. So this tally, right, it's just to like take down the numbers that you have written down. For example, I have counted 1, so I put 1, and I saw that there's like five values of 2, so I put 2, 2, 2, 2, 2, 2. So this is just like for you to like count how many times this 1 or 2 or 3 appears. So in this case, right, to make this is to like make you look at the stats easier in terms of like 5, because 5 timetables is easier to count. So when you have a sets of 5, you put the 4 straight down, 1, 2, 3, 4. Then after that, you put a horizontal line across to represent the last 5. So we have like two sets of this sort of like cage. It means like 10. So in this case, right, this one is 5. This one is 6, because this one is one set of 5, and there's a 1 here, this one is 6. So how do I know how do this table frequency come about, right? It all comes from your initial data over here. So I can see 5 times this 5 appear, 5 times these 2 appear. So let's check whether there's like 5 2s over here. 1, 2, 3, 4, and 5. So this is how we can get the frequency of 2, because it appears 5 times in this list of data here. So that means, right, the frequency table just tell you like how many times this number appears. So sometimes you're also required to like given like a frequency table, then after that you can use it to like draw a dot diagram or histogram. So you can like use this data here to like transfer to another form of representation. Because all these 4 representation, dot diagram, histogram, stem relief diagram, and another histogram. All these, right, are just different way of like representing a data, so that it'll be easier for the reader to read. Okay, so for a histogram, right, whenever is a single value, that means it's a ungrouped data, you put the numbers right in the middle of the histogram. So the area of the bar, right, actually is proportionate to the numbers they represent. So the length, the width of each bar over here, you must always like draw it like equally. So when you vary the height, right, the areas will always like vary according to the numbers they represent. The number of times this particular number appear. So, yep. So the height of each rectangle will be the frequency of the marks. It means, right, how many times this particular number appear. So now for the histogram for group data. Okay, so at the start, you'll be given this raw data over here, whereby the data are not arranged and like all over the place. It's very hard to like see or analyze. So we put them into class interval. So class interval means, right, you'll be given a range, and after that you need to count how many numbers, right, fall into this range. So for example, from 25 to 30, so you must always notice the equal sign at the bottom. So the equal sign at the bottom means, right, it includes that particular number also. So for 25 to 30, let's check. There's one here, 1, and this one is not counted because 30, there's no equal sign at 30. So 1, 2, and yep, there are 2 of them. That's why you put 2 strokes here, and the frequency will be 2. So let's look at the class interval of 40 to 45, whereby 40 is included. So they say that there's like 10 datas that fall into this range. So here's 1, here is 2, no, this is not. Okay, so I also need to get a trick. This one is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are like 10 numbers over here that fall into this range of between 40 to 45, inclusive of 40. That's why you put 10 strokes here, and the final stroke of the 5, right, you put a horizontal line. So there's 2 sets of 10, 2 sets of 5. So that's why you get a frequency of 10. So normally this class interval, they will be like proportional. For example, I start with 25 to 30. The next one will be 30 to 35. So you can notice, right, if there's an equal sign at the next number, you won't have an equal sign at the last number of the previous class interval, because we don't want to like double counting. Means we like count the data 2 times. this will give us a lot of like inaccuracy, and we will notice that the total number will be higher than expected because we double count a number. For example, I count Ryan, then I count Ryan again, then I count Ryan again. So I count Ryan 3 times. This one is like not fair. Yeah, so for class interval, right, as in for group data, whenever you want to plot a histogram, right, all your, because you notice that they are in range, right, when you plot a histogram, your histogram, the rectangle, right, will be in between two numbers of the particular range that you're drawing. For example, 25 to 30, right, you see a rectangle between 25 to 30. And after that, the next rectangle from 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, and 55 to 60. Yes. So this is how you draw a group data for a histogram when you have a class interval. Yeah, so this is another attention also. Some keynotes. Okay, so we have basically like go through the content for chapter 14. So if you can't understand some parts, you can like relook this video again. And please do some highlighting and write some like notes down so that when you revise this chapter, at least you know what to revise. You don't have to like keep on repeating the video by itself. So we have like looked through chapter 14. Now we are moving on to chapter 15. So you must think, right, what are the links between chapter 14 and 15? All I can see is like diagrams here, diagrams there, diagrams everywhere. Okay, so before I move on to that, let me give you a short pause to give you a science pun because I run out of like math pun. Okay, so why did the scientist take off his doorbell from home? Okay, so the reason being, right, the scientist took off his doorbell from his home because he was hoping to win the Nobel Prize. Okay, so Nobel Prize, right, is like the most prestige, the most, can say the highest award that can be awarded to a scientist, right? Because he made a very amazing discovery. Yep. So I hope you understand this pun. It can be a bit lame, but yeah. Okay, so now let's move on to chapter 15. Okay, so in chapter 15, right, now we want to like analyze the data further and like tell more things about the data that we have collected since you like take so long time to like collect it. So we would like to look at like how can we analyze the data further and how do we compare between different groups as well. So that's why we learned about the three main things in chapter 15. We learned about calculating the mean, which is the average that you have been calculating since primary school. Then after that we look at something new called the median, which is to find what is the middle value. And lastly, we find out what is the mode also. So when you heard the word model or mode, it just means, right, the most number of times a value repeats, or you can say most common number that appears. So the word common, right, also means, right, mode also. It means that the most number of times this particular value repeats. So that one will be a mode. So let me bring you to the textbook. Mean. So in order to calculate mean, basically it's the sum of datas divided by the total number of datas. For example, if I have like three masses over here, 40, 45, 53, the sum of data will be my total weight. And the total number of data will be 3 in this case because there are like 3 persons. That's why I take the total weight divided by 3 to get 46 as the average. So this one is still not too bad. So this is how you find mean. So for median, there are basically like a few steps. So step 1, you need to know how many datas are there in the first place. For example, in this case, right, there's 1, 2, 3, 4, 5, 6, 7 datas. And after that, you need to find the position of the middle number. So in order to find the position of the middle number, there's a formula that we can use. So we take n equals to 7 plus 1 divided by 2. You'll give me the fourth position. Okay, so why do we need to use this formula, right? It's because when our data, when the total number of data is like too many, we can use this formula to help us calculate. So for example, in this case, right, the data is like just 7 data, so it's still quite easy to count. That's why we can still like just use our eyes to observe which one is the middle value. So after that, when you find the middle value, you can actually arrange them in order. So normally I will like arrange first, count the number of data, then I will find out the position of the median and find the median. So in this case, right, it's at the fourth position. So it's 1, 2, 3, 4 here, right in the middle. There are 3 numbers on my left side and the 3 numbers on my right side. So this one is right exactly at the middle. That's why 22 is the median. So some of you might ask, why do we need to find median? We'll find out later. Don't worry. So just now we look at like odd number set of data. So here there are like 7 data here. Now what about the even number of data? So in this case there are like 8 numbers over here, 8 data. And you realize that the middle position, right, now is there's a decimal place. So what does it mean? It means, right, this number is between 4th and 5th position. So let's look at the data. So the 4th number is this one, 12, and the 5th position is this one, 14. So in order to find what's the median is right in this middle line here that we are unsure of what is it. So that's why we need to use the average. We take 12 plus 14 divided by 2 to find out what is the number right in the middle. Just an estimation. Yeah, so no need to worry about like when to use what or when to use that. So as long as you can follow this step properly, find number of data. After that, you rearrange the numbers. Then you find the middle position, the position of the median. So if it's a whole number, it means that you just need to count. And after that, this will be your median. If it's a decimal, like 0.5 something, it will always be 0.5. If it's a 0.5, it means, right, you need to find out what is the median between 2 position. For this case, it's 4 and 5. So if it's like 5.5, it means, right, you need to find the median between 5th and 6th position. So how to find that, right? You need to find average. That's why we take 2 numbers, add them together and divide by 2. Okay, so the last one will be the mode. Mode means, right, the most frequently this value appear. So in this case, right, this derivative diagram, the mode will be 59 because the 59 appears 5 times. 1, 2, 3, 4, 5. So it's just the highest number of a particular number that appears. So this one is like the easiest among the 3 of them because you just need to observe which one is the highest numbers that repeat so many times, and after that just write it down. That's all. So normally students don't have any issues with like finding mode. So the next part will be like, when do we use what? So normally mean, right, is usually preferred over the median and mode because all of the values in the data are used in calculating the mean. And it will be the most reliable measure, provided there are no like extreme values. So when there are extreme values, right, this is when you need to use median. For example, most of the household income falls within 2,000 to 3,000. Then suddenly there's one household income, right, from a very rich family, all the way at 10,000. So this 10,000, right, will basically increase the average of this group of data. That's why you use median to calculate. So if there's no extreme value, you will use mean. And when it has an extreme value, you use median. So don't worry, like you will be given a question that we don't know, that you won't know what to use, right? We always tell you like to calculate mean, median, or mode directly. But whenever you come to the last part, whereby it's the describing part, right? Like for example, why do we like you're asked to calculate mean, and after you're asked to calculate median, and which one is better to like represent this data. So this is where you need to give this explanation over here. Okay, so mode, right, is usually like used for business planning. For example, there are like 30 students in the class, and you want to do a survey on like which is the most popular transport taken by student. Is it the bus, or is it the taxi, or is it the private car? Yep. Okay, so this one is a summary. Okay, so don't be afraid by these terms over here. It just means, right, the total sum, the total value divided by the total number of data. This one is just a mathematical way of writing it, so don't have to like worry about it. So as long as you know that mean is equals to sum of the data over the total number of data, then you are fine already. You won't be asked to like write this one in the exam. So the mode is the value that occurs the most frequently in the set of the value, and for median, right, is the middle value after the data has been arranged in ascending orders. So for mean, it considers all data values and is easily affected by extreme values. So if you have a very like large number right at the end or right at the start, a very small number, it will like shift the mean, and it won't give you a very proper or accurate indication of like what is the average income of a particular class. So when you see any extreme values, it will be the best time to use the median, because median will like shift according to the extreme values, and you will not be affected by extreme values. Okay, now let me give you another science pun. So they teach in my science class that the first animal to go to the space was cow, because the cow jumped over the moon. Okay, so if you have any questions that you would like to ask about math, you can always use the consultation slot during our math period, like later. I will send out a Google link on SLS so you can like, access it. And next week onwards, if you need to ask any questions or consultation for math, right, you can do so. We can like arrange a consultation if you need one, or you can just text me, or we can just do some online consultation also. Okay, thank you.